Hello everyone and welcome to this edition of Inside the Naval Postgraduate School. From our campus in Monterey, California, I'm your host Alan Richmond right here on the Pentagon Channel. Welcome to the show. Well, in this episode we'll travel to Camp Roberts for part 2 of the relief exercise we brought you last month. We'll also head to San Francisco Bay and get involved with the Marine Interdiction Operation on port security. But to start the show, we had the honor and the pleasure recently of meeting with the commander of U.S. Cybercom and the NSA, General Keith Alexander. General Keith B. Alexander, United States Army, is the commander of U.S. Cyber Command and director of the National Security Agency. He's also Chief Central Security Services at Fort George Meade in Maryland. As commander of U.S. Cybercom, he's responsible for planning, coordinating, and conducting operations in defense of the DoD computer networks as directed by U.S. Stratcom. As the director of NSA and chief of CSS, he's responsible for a Department of Defense agency with national foreign intelligence, combat support, and U.S. national security information systems protection responsibilities. NSA, CSS, civilian and military personnel are stationed worldwide. General Alexander holds a Bachelor of Science degree from the U.S. Military Academy and a Master of Science degree in Business Administration from Boston University. He also holds a Master of Science degree in Systems Technology, Electronic Warfare, and a Master of Science degree in Physics from the Naval Postgraduate School. Well, General, thank you very much for taking time to appear with us here on Inside NPS on the Pentagon Channel. It's an honor to have you visit NPS.
Thank you. Thank you.
Students are now graduating through the NPS Cyber Systems and Operations Master's Program, some of which have been assigned to U.S. Cybercom. Wondering if you can speak to the benefits of having officers with a dedicated graduate-level cyber education at your command.
I think one of the most important things we can do for our students here is to prepare them for the future that they will play in the military. From my perspective, having people that are educated and understand the technical sides of cyber, especially the information technology, computers, how they communicate, how people hack into them, and what you need to defend, takes great technical skills. What the graduate school here does is help train people on that fundamental level of how these things operate. And what the students will be able to do is to take that deep technical understanding and apply it to the military and put it in military terms to say, here's what this means for the future of our military. What we need to not only operate, defend, build our networks, but if needed, how these can then be used for military operations around the world in support of our forces. So I think what this does is it brings a great bridge from the technical side to the operational side, which we will need in the future in this area.
NPS has also developed an Applied Cyber Operations Master's Degree program targeted to senior enlisted service members with the first cohort set to graduate in September. How does advanced education targeted to the enlisted cyber workforce help U.S. Cybercom and DoD achieve its mission in cyberspace?
And one of the most important things that we could have is people who really technically understand how systems work. The more they understand how computers and the information technology that links these computers together, the more they understand that, the better they'll be able to defend, operate, build, and use them as a weapons platform for the good of our nation. To do that, though, they have to have that deep technical understanding. I believe educating our military force, enlisted and officer, is one of the most important things that we can do, and we really appreciate what you're doing here to help build that force in this area.
Of course, NPS has spent decades conducting research in information assurance and security and has added offensive cyber operation planning and analysis to its portfolio of student-driven research. General, can you comment on the value of applied advanced research to the mission and requirements of U.S. Cybercom?
I think the great things, and I think Professor Dorothy Denning is one of your lead professors here on that, so thanks to what she and the whole department is doing in this area. From my perspective, understanding the vulnerabilities and the ways adversaries will try to access our systems or shut them down. These types of things take broad training, education to understand how this is going to work. So if you think about a distributed denial of service attack against our country and then see how that attack is actually going to go, our military force has to understand how that actually works, where the command and control sites are, where the hot points are, what that means, and now how would you take that on to eliminate or mitigate that threat. Jump up a level to destructive ones. The educational foundation that you can provide will help them look at, how do I defeat a threat like that against our country? If they don't understand it, if they really don't technically understand it, they're not going to be able to help stop it. So from both aspects, from the officer ranks and the enlisted, we have to build a force that understands fundamentally how that operates. So you're creating the equivalent in cyber warfare as what we had in naval warfare and ground warfare. They have to complement each other, but we have to train that force on how to actually use these instruments for the good of our nation.
The realm of cybersecurity and information technology evolves rapidly. What do you think the future holds for the U.S. Cybercom mission, and what would you as NPS do as an institution to support that effort?
Well, the mission for U.S. Cyber Command is evolving. As you now know, we're responsible for defending the nation from a cyber attack, as well as operating, building, and defending the DoD networks. When you think about that mission set, we, the Defense Department and the U.S. Cyber Command, are responsible for defending this nation. And so if you think about it from a terrorist perspective, missiles, other forces coming at us, in my opinion, the easiest to use for other nation states is going to be cyber. That's where we're going to be challenged the most and in the near term. So we have to build the force and train them and get them ready to do that. Our nation is going to depend on us to be able to do that. So this training and education platform that we do, the better trained they are, the more successful we'll be in accomplishing our missions.
I'm wondering, during your time as a student here at NPS, what are the tangible benefits from your education and research efforts that helped you in your career?
I think one of the great things that I got here was a great understanding in systems technology. From my perspective, there were two kind of lines that I was working, EE and physics. In those 2 degrees, the EE, we actually did our thesis on computer-aided design of fin-line structures and waveguides. What that gave us was a great understanding of the technical portion of how instruments communicate, what you could do to change it. Think of it, Schrodinger's equations, it's all good stuff. What that helped me do, when I left here, I went to Fort Huachuca, Arizona, and I was asked to help write the MI story, the military intelligence story for the Army. And in doing that, I dealt with a lot of senior officers trying to help translate how radar systems and radio systems were collected by our intelligence assets, and how far that worked, how those worked, where the gaps were. And based on what I got here, I was able to explain technically how these operational systems worked in such a way that it caused us to change parts of our future for the Army. It was a great time. And so I believe what you're training now in cyber, you're going to have students that are going to go out there now with a new understanding of cyber. They're going to change the future of our services in these areas, and I think that's great.
NPS Interim President Rear Admiral Jan Tighe served as your executive aide some years ago. Wondering if you can share your thoughts on returning to NPS and having her preside over your induction into the university's Hall of Fame.
Well, I think the world of Jan Tighe. She is absolutely a superb officer. Before she came up to be my exec, she was the commander at NSA Hawaii, ran that facility, did an absolutely superb job. As you know, she had a PhD in GSM technology from, let me think, Navy Postgraduate School. And when I look at the types of officers we need in the future leading in cyber, the first person I think of is Rear Admiral Jan Tighe. She's the best we have across all the services. She is absolutely superb.
What are your sentiments about being inducted into the NPS Hall of Fame?
Shocked, stunned, and amazed. You know, it's kind of interesting. I was telling one of the other folks there, my class, when I graduated, I had a great time here, I really did. We learned a lot, had great friends. My thesis partner was a Navy guy, Steve Hamill. And when you think about it, if you had asked me then, when I was graduating, that I would be inducted here today, we would have all laughed and thought that's the craziest thing I've ever heard of. It was an honor and a privilege to go here. I learned a lot. And one of the things I learned was the value of a technical degree that will help our military employ capabilities for the future, for the good of our nation. I think it's helped us in Iraq, it's helped us in Afghanistan, and it's helped us evolve and transition NSA to where it is today. And I think those are all good things. So I am a little bit stunned that they would induct me, but I heard they're doing it alphabetically.
Final question, what is your advice for this quarter's graduating class here at the Naval Postgraduate School?
I think the best advice I could give them is to think, when I graduated here, it was 1983. At that time, ARPANET was just coming out. We were transitioning from the old network links of communications to the TCP, the Transfer Control Protocol, Internet Protocol, the way that our packets transition today. That fundamental shift to packet technology has changed the world as we know it today. And when you think about it, what we learned, and now what's evolved over the last 30 years, has changed society. You know, you think Google, Facebook, Apple, all these things have evolved from that technology. And the communication systems that we have changed. And it's a different world for our military to operate in. For the graduating class, I would tell them, look back and see how much has changed. And now look forward to the future, the change that you're going to be involved in. You are the people who will lead the future for our nation and the military. The better you're educated, the better you're trained in these areas, the better you'll lead our forces in the future. And I think this is a great place, a great institution to help train our people. So thanks for what you do here.
Well, General, thank you very much for taking time to appear here on Inside NPS on the Pentagon Channel, and our best congratulations for being inducted into the NPS Hall of Fame.
Thank you. Thank you very much.
Well, special thanks to General Keith Alexander. Well, stay with us. Coming up after the break, we'll travel to San Francisco Bay and the Marine Interdiction Operation and our efforts on port security. Stay with us. More to come right here on the Pentagon Channel. Welcome back to the show. Well, recently we had the opportunity to head up to San Francisco to be involved with the Marine Interdiction Operation. What is it? International team of researchers, special forces operators, first responders, and scientists led by Naval Postgraduate School, Department of Information Sciences Associate Professor Alex Bordetsky and the Lawrence Livermore National Lab recently conducted a globe-spanning experiment designed to detect and destroy shipborne nuclear threats. The experiment, dubbed MIO 2013, incorporated the NPS Tactical Network Testbed, or TNT, and Maritime Interdiction Operation, MIO, groups, with field experiments conducted by the NPS Center for Network Innovation and Experimentation, CENTEX, and international partners from a diverse array of disciplines. Here's Alex Bordetsky to explain.
Yeah, the key word MIO stands for the Maritime Interdiction Operations. And in the title and the focus of the project, it is essentially the central part of our networking and interagency collaboration studies focused on countering maritime-sourced illicit material trafficking threat. And by saying illicit material, I mean radiological, nuclear, chemical elements, and other components of possible terrorist-driven threat to the areas of responsibility. So this project is our next significant step in the direction of countering the threat through ubiquitous networking of all parties and real-time collaboration. So you can view it as an interplay of the network of coalition special forces units following the target in the maritime domain. It started in Baltics, then unfolding through the large area of land target following, jointly with Norwegian 10th Special Forces Group and Polish Special Forces units, then proceeding into the maritime detection and interdiction area played out in San Francisco Bay. So the three networks, the networks of special forces units on site of action and threat finding, collaborating in real time with the growing network of experts worldwide, and also unattended and driven by robotics sensor networks. So the interplay of these three networks, the way we can coordinate their activities and put them together, was a subject of the experiment.
Well, some of this new exciting technology includes a throwbot. Todd, tell us a little bit about this device called the throwbot.
It's the Recon Robotics Throwbot XT. It's a 1.2 pound reconnaissance throwable robot. Basically what you have is titanium casing, you have a TV camera, a reconnaissance camera, you have an IR illuminator so it can go from light to dark. It'll see in complete darkness. You can find an object or a person, a perpetrator, in complete darkness 25, 30 feet away. It has a stabilizer, robust wheels. It allows it to traverse over 2-inch obstacles. The antennas are your radios, and then you have a 1.8 pound operational control unit. 3 pounds for the dismounted soldier to carry around.
Now, how is this activated? It looks almost like a hand grenade with that ring on it.
It's ergonomically, that's exactly what it is. It's you pull the pin, it actuates the robot, it turns it on, turn the OCU on, operational control unit, and you have instant feed. There is no boot up time. And then you can throw this wherever you want to see or where you can't see, so you can have situational awareness in a place that you have no idea what's behind that wall, what's up on the roof, or what's down a ladder. Right now they're using this robot. There's about 2,000 over in theater right now, used by mainly the Army and some other forces. For a maritime interdiction operations application, that's exactly what you would do. You would pull up alongside before you do the hook and ladder on a high freeboard ship. You can actually throw this on the deck and have situational awareness on the back deck before you do the hook and ladder. And as you're doing that, if you had a perpetrator or bad people coming on the aft deck, at least you'll know that and you'll be prepared.
Well, since this is an international operation with international partners, we talked to some of our friends from Canada. Jason, tell us a little bit about your participation in the Marine Interdiction operation here. Now, your team is from Canada, I know. Tell us a little bit about what you're doing. We were on the ships yesterday, patrol boats, and we're on the bigger ship today.
Well, what we bring to this experiment is more of the subject matter expert of interpreting detection equipment. So we were on ship, boarded both ships, and we were actively searching for any kind of radiological device or anything that was given off a really hot source. So we were able to use our detection equipment that we got some detection equipment we're familiar with and some new detection equipment. So that was great also to be able to use somebody else's detection equipment and be able to understand it and interpret the information that's coming off the device, to be able to send that off really quick. So the biggest thing that we bring to the table is we are your detection. We're the detectors, the human detectors aspect of this experiment, and being able to assist the other members of the team to interpret that information so that they can make those command decisions that they need to make.
Now, anytime you have an exercise, you have little glitches here and there, and we've had a few of those. But overall, how is that collaboration going on this exercise?
This is really good. I'm not used to the fluidness of this exercise. I mean, because the dynamics have changed from the beginning of the day to the end of the day, and that really puts a challenge. An example today, finding our sources on this huge ship was a challenge, and we almost had to be on top of these sources so that we can get the data. That was a challenge in itself. So those are your little hiccups that we have every day, I guess.
Well, so much of these experiments involve collaboration, and certainly Canada has been a long-time partner of ours, and thank you for working with NPS. From your perspective, you take new knowledge back to your country as well.
Absolutely. There's some new stuff here that is just really cutting edge, and it's energetic to see the passion that everybody brings to the table. There is some stuff here that I can't wait to go home and discuss, to say, how can we use this to better, what we do so we get a better product out there. I'm pretty excited, really.
Well, stay with us. Up next, we go to Camp Roberts, California, and a look at the Desert Hawk. Stay with us right here on the Pentagon Channel. Well, up next, we're headed down to Camp Roberts, California for some relief. Relief provides an environment that fuses interactive community building and knowledge sharing activities with concept-based socio-technological experimentation. Since 2009, Relief has brought humanitarian practitioners, technology developers, federal civilians, and active-duty military personnel together for hands-on collaboration. The multi-institutional field setting provides a semi-structured learning environment promoting collaboration and relationship building across an increasingly diverse response network. Here's Jim Grove from the Department of Homeland Security. Jim, tell us a little bit about your area of responsibility and how it relates to first responders.
I work in the Interagency Office at Science and Technology and support our First Responders Resource Group with partnership development, program management activities, and work with them to closely monitor the things that's being developed with the first responder community, with operation requirements documents, and then trying to take those and bring those into this kind of environment where we can interact with the private sector, small businesses and others, the academic community, to see what those leading edge technologies are, some of the things that are emerging, the things that we need to be aware of so that we're not duplicating processes and things that are out there, and also being able to leverage those technologies that are well advanced and being able to tweak those for the community. We believe that there's no 100% solution for everything, so if we can find something that's a 50 or 60% solution and then help to bring that to market at an 80% and realizing that extra 20% is then done at the local level for their tactics, techniques, and procedures, that's the kind of things that we're trying to get at.
Well, certainly with many disasters around the world, first responders face many challenges. What are some of the good things that have come through all this collaboration to help support them?
Brought really the community together, and our first responders group is really trying to become that focal piece within the federal government community to bring others to the table from our interagency partners, academia, and others to come together and say, you know, what are these larger problems? And while we don't have the money to spend on all of them, you know, everybody is doing great work. So let's be in concert with one another. Let's understand what the first responder space looks like, what that future is, and really build towards the future, taking incremental advancements, and then looking forward to that first responder of the future and protecting them and integrating these things together and trying to reduce some of the weight. You know, a lot of times we come up with technologies that are introduced as a one-off kind of thing that does a certain or solves a certain problem, but trying to integrate those together so that maybe the next turnout gear has the integrated pad device on it and able to communicate and be able to track first responders, those kinds of things, and try to improve the protective posture and the safety of our first responders.
Well, to be a first responder in the first place, it really does take a very special kind of person, doesn't it?
I think it does. You know, I always say, you know, you're kind of a crazy person if you run into a burning building, but you know, that's the kinds of things that people look up to, you know, when they do those kinds of things. And you know, we saw that recently in Boston with the heroics that we saw up there, and you know, people running to help other people. You know, you see, you know, the normal thing I think for most people is to run away when they hear an explosion, but you know, you found lots of people running to help other people and come to their neighbors' aids, and you know, that takes a lot.
For any first responders that might be watching the program, what would you like to say to them?
I think science and technology is really dedicated to supporting them and helping them. We know that they have lists of things that they're trying to get accomplished, and we realize that their budgets are small and ever decreasing, so we want to make the most impact and advance those technologies and provide them what it is that they need to get their job done and do it much better. Not just concentrating on those big departments and the UASI regions, but getting down to those small departments and making that an affordable thing. And you know, one prime example is our multi-band radio. I mean, we heard what the first responders needed and wanted, and we worked with companies to bring that to market. And we believe that's the kind of advancements and the kinds of things we want to do at Science and Technology.
Well, another component of the field testing was an unmanned vehicle which took flight called the Desert Hawk. Todd, tell us a little bit about the Desert Hawk.
Sure. The Desert Hawk EER that we're flying out here this week was developed for fuel cell research for the Air Force Research Lab. So this aircraft, there's 3 of them in existence, currently flying on electric power. In a few weeks, we're going to be going up to Fort Drum, New York,
to fly it on the fuel cell for the first time, which is kind of the culmination of all the effort and the iterations of this aircraft. What we also use it for is demo events such as Relief. We've been out to GIFIX, other events, AWE. And this week we're flying primarily a payload for Lockheed Martin down in Georgia. It's a radio relay. And what that does is basically you put the aircraft up in the air, allows many different on-the-ground organizations to crosstalk with different radio bands so the communications can go everywhere. And yesterday we put it up, worked as planned. Everybody was really happy with the results. And
we had an interesting landing.
We had an interesting landing yesterday, that's right. So sometimes what happens is you can't always plan for the unexpected. So we don't normally fly the aircraft as high as we did yesterday, and we had a hard time getting it down. So when we finally got it down, what we did is make an autopilot change last night to an autopilot that gives us more control to bring it down, basically. And what you just saw was a successful flight because we have more control manipulation now with a different autopilot.
Well, that's it for this edition of Inside the Naval Postgraduate School. From our campus in Monterey, California, I'm your host, Alan Richmond, right here on the Pentagon Channel. Take care.